afternoon, students. Now we discuss something computer networks. First of all, what is computer networks? Today, discussing about also the TCP protocol stacks in computer networks. First, we think about what is computer networks. So the collection of autonomous computers interconnected with simple technology. So connect all the devices of networks connected in a single technology. It is called a computer networks. So what is the connectivity? The connectivity occurs between two computers. So using in a physical mode of the example coaxial cable, optical fiber cable. These are all used physical medium of data to be connected in devices. So in this physical medium is a represent what link between one or more devices in between of components. It is called nodes. So many devices are connected in a single technology already told that. So it is represent the physical medium of components is like in a nodes. So when a physical link occurs between the pair of nodes, it referred point to point. So point to point means when a physical link occurs between a pair of nodes, this referred as a point to point. So more than one nodes to share the data in a single physical link, it is referred as a multiple access. So single access and a multiple access of data to be shared among the physical medium of devices. So another one important is a switched network. So the switched network means the devices are connected through in a switched manner of example telephone system in a postal system of two-way, that is circuit switched network. Another one is a packet switched network. The packet switched network, the nodes are in a manner of discrete blocks of the data to be connected in each other. So it represents the called packets or messages. That is called in a packet switched network. Then how the data are stored in the packet switched network. In this technique, each node it receives data from the packets around the link. That is nodes and then links. That is called a packet switched network. So another one is a circuit switched network. It first establishes the network across the link. That is, it how to be allows all the node of data in each stream of circuit. So take example source to destination. Okay, all the devices are switched to be connected in each nodes of links. That is called a circuit switched network. So example of such circuit switched networks, the nodes are connected in a circular manner. That is called in a circuit switched network. So the mandatory requirements of using in a computer networks is a point to point and multiple access point links. Another in that of what type of switched networks can access the data. So before that, how to access the data using in the scale of data, that is in the capacity of the data to be transferred from one source to another one destination. Okay, so more services are used in a computer networks. Such things are in a logical structure, physical structure of the data how to be used in computer network requirements. So in this computer networks, the implementation of used in a architecture model, okay, that is called in multiplexing and demultiplexing, encapsulation. Then another in the protocols, layering and protocols. These are the network architecture. So it is classified in that of implementation of a network, how two-way. One is OSI architecture, another one is TCP IP architecture. It's very important in that of in a data communication in a computer networks. So layering and protocols means when the system it gets complex, okay. When sharing of the data to be transferred from one node to another one node, the system designer to introduce the abstraction of the data. That is how to encapsulate the data to be communicate through in the interface of the objects. It is called decomposition. Okay, another one is important in the data communication in a computer networks is a protocols. So protocol is a set of rules that governs a data communication. It should be obey the rules and regulation how data is communicated from the source to destination. It also defines how to communicate it, how to what is communicated, and how the data to be connected through in a timing, and then that is sending and receiving of the data such a way of sender to receiver. So another one is a encapsulation. It is a control the information. It must be added with the data, that is interconnect in a peer-to-peer or multiple access of the data to be received from the center. So it is used in the of depends on the header messages, that is how the data to be defined in a header and a trailer, then data sent by the program using in a payload, that is in the message of the body. Okay, these and all implemented in the architecture of network. So another one that of multiplexing and demultiplexing. So the switching, the packet switching or circuit switchings are used in a multiplex of the data to be how the data shared from single physical link to peer-to-peer link. It is defined in the how to adding the header messages in the body of the messages. Okay. So again, I told that in that of multiple flows of the data, how to be shared over the physical link. Okay. So the adding of when attached one or more nodes in the link, additional informations are shared from the sender to receiver. In this type of messages, how to identify the data from sender to, that is source to destination. Okay, it is also known as a demultiplexing in a data. It also gives the address of the data when communication from source to destination. Able to understood? Okay. So the messages are demultiplicated using in the destination side. Okay, that is from source to destination. That is in the called in the multiplexing and the demultiplexing. The start 4 times it is used in the option C, the network layer 4 times and the data link layer 6 times. The next question, choose the best matching between group 1 and group 2. So group 1 data link layer, Q represent the network layer, R represent transport layer. In group 2, ensures reliable transport of data over a physical point-to-point link. 2, they encode and decodes the data for physical transmission. Third, it allows end-to-end communication between two processes. 4, it routes data from one network node to the next. So the answer is A. The data layers are from P1 is a data link layer, the network layer, then network layer of routes data from one node to another one node. So the next question, what is the protocol data unit at the data application layer in the internet stack? So the answer C, message. Yes, application layer is in the form of data is using in a message. So that's all in a OSI model. So the next TCP IP model. So reduce the architecture of network layer in a OSI model is called a TCP IP model. It is a reliable model of developed using in the OSI model architecture. It is not exactly similar to the OSI model. Okay, so session layer and presentations layer. So two layers are reduced. Totally TCP IP model having 5 layers, working the principles of protocol and layering approaches. Its model is a consist of 5 layers, that is application layer, transport layer, network layer, data link layer, and the physical layer. The first 4 layers provides the physical standard network interface, inter-networking, and transport functions. It is correspond to the first 4 layers of the OSI model, and these 4 layers are represented in TCP IP model by the single layer is called application layer. TCP IP அப்படின்றது is a hierarchical protocol made up of interactive modules and each of them provides specific functionality. So this is a TCP IP model packet format. So application, presentation, session, transport, network, data link, physical layer. So the application layer, the using of application, presentation, and then session. That is simple mail transfer protocol, file transfer protocol, hypertext transfer protocol, domain name system, simple network mail transfer protocol, telnet. That's all. In transport layer has having the services of ACTP, TCP, and then user datagram protocol. In network protocol using ICMP protocol, IGMP protocol of using the IP address of address resolution protocol. So in the data link layer in the form of frames, the data link layer in the form of bits of the data to be transferred. It's to be reduced in the host network. So the bottom of the layers are called in a network layer to connect the host into the network. So internet layer, it is one of the layer of using in the OSI model. It is responsibility of delivering the IP packets to their destination. So in this layer is called IP. So it is unreliable and connectionless protocol. It is used in the packet. It's called datagrams. It keeps not tracks all the destination of the data. So this is the packet format of using in a IP datagram, that is Internet Protocol. So IP header here for time to leave the data in a packet, then protocol header checksum the data transfer during the time the data transfer when lost or um, corrupted the data. So here the source IP address, destination IP address, then checksum of the data, then data is having. So totally 32 bits of the data have using in a IP datagram. The transport layer is a similar functionalities of the OSI model, either the connection oriented or connectionless protocol. So the TCP IP protocol is a reliable connection of using the various functions, that is error control, flow control, sequencing of the data. Then user datagram protocol is an unreliable connectionless service. So the packets are reached at the destination. So error checking and then sequencing of the data. It is very good for in a real-time applications of data to be sent in a large database. So UDP it consists of in a packet format, that is having in a source port address, destination port address, checksum. The source port address is the address of the application program that is created the message. Destination, the destination port address, the address of the application program that receives the message. The total length, it defines the total number of the bytes how to be transferred in a so host to another one host, usually in a user datagram in bytes. Checksum, it does not contain any ID of the data segment. So in this of application layer, so it is the combination of application layer of presentation layer and the session layer in the OSI model. It provides the fully connectionless communication of messages from one source to one host to another one host using different applications of example web page design. So the application layer, it includes high-level protocols that are used for a wide variety of applications, that is FTP, file transfer protocol, SMTP, DNS, domain name system, and then telnet, terminal network. So in that of TCP IP model is also working the principles of protocols, that is under the protocol of HTTP, Hypertext Transfer Protocol. It stands for Hypertext Transfer Protocol. This allows us to access the data over the wide web in the www. It transfers the data in the form of plain text, audio, video, animated video, audio. These images are transferred around the world wide web. It is called in a HTTP. Nowadays, we are using in the form of HTTP in the web pages of network connection. So it is nowadays in online classes are achieved through in the protocols of using in application layer. So it is also known the hypertext transfer protocol. It is efficiency to use in the hypertext environment where are the rapid jumps from one document to another. So click the web pages. One page having one or more result pages how to be communicated in a using in a hyperlink, that is a hypertext. It is highlighted in the each and every web pages of communication in the hypertext. SNMP, Simple Network Mail Protocol. So it is one of the protocol to be managing the devices on the internet by using TCP/IP protocol suite. SNMP, then SMTP, that is Simple Network Transfer Protocol. When the files are transferred from one device to another one device of address. Example, email address. So the similarities between OSI and the TCP/IP. So the both are based on the concept of a stack of independent protocols. In this functionality of layers is roughly similar. The network, it is a network-oriented approaches of using in a TCP/IP model. So the 7 layers of OSI model and then 5 layers of TCP/IP model. It provides the clear distinction between services, interfaces, and protocols. This also TCP/IP does not provide clearly in the services and the protocols such in a network architecture. So it is a purely connection oriented protocol. It is a connectionless protocol. So OSI data link and the physical layer are separate layers. So in these layers are combined in a host network. It is not fit for the OSI model. So compared to the wired and wireless communication, okay. So the OSI model of architecture easily implementation of in the network architecture using in a wired connection. The wireless connection will go for in a TCP/IP model of application layer without wired. So consider the network with the routers R1 to R6 connected with the links having weights in the following diagram. So all the routers use the distance vector based routing algorithm to update their routing tables. Each router it starts its routing table initialized to contain an entry for each neighbor with the weight of the respective connecting link. So after all the routing tables stabilize, how many links in the network will never be used for carrying any data. So consider this diagram R1, R2, R3, R4, R5, R6. So these nodes are connecting the link with the respective router. So each router it starts with its routing table. It is to be initialized to contain an entry for each neighbor based on the weight. The weight given the R1 to R26, R2 to R3, 2, then R2 to R4, 7, then R4 to R6, 8, like that. So, which is the answer how to be, how many links in the networks will never be used for carrying any data. So, the option is used answer 2 with carrying the data from one router to another router. Okay, thank you, students. In this session, discussed about OSI model and the TCP/IP model, how the working principles of under the protocols of layering approaches, uh, with the questions. Thank you.